get started today, let's begin with the x-intercepts for the following equations. So remember, whenever you're finding an x-intercept, that's where we want to let y be equal to 0. So in this case, I would have 0 equals x squared plus 5x plus 6. And whenever we're looking to solve for x, to figure out what x is with a quadratic, we want to put this in factored form. So this is simple factoring. Two numbers that multiply to 6 but add together give me 5 are going to be a positive 3 and a positive 2. I then take each bracket, put it equal to 0, and solve for x. And I get x equals negative 3 and x equals negative 2. So finding x-intercepts is all about setting y equal to 0, and then of course factoring so that we can set each brackets equal to 0 and solve for x. Same thing down here. We're going to get 0 equals 2x squared plus 7x plus 3. And then this is decomposition. So two numbers that multiply to 6 but add together to give me 7 are going to be 6 and 1. So 2x squared plus 6x plus 1x plus 3. And then if you remember from our factoring, when we have 4 terms, we use factoring by grouping. So let's common factor the first 2 terms. Common factor the second 2 terms. Well, there isn't anything, so I'm going to put a plus 1 as a placement holder. And then from here, x plus 3 is my common set of brackets, leaving me with 2x plus 1 equals 0. And now I'm going to set each of those set of brackets equal to 0. Let's subtract 3 from both sides, and I get x equals negative 3. And then over here, I'll subtract 1 from each side. Oops, negative 1, and then divide by 2. And that gives me x equals negative 1/2. So x equals negative 3 and x equals negative 1/2. And those give me the x-intercepts. Now, the reason why I'm interested in the x-intercepts is because it's going to help me with today's lesson. So we've actually seen this before. It was a long time ago. It was in Unit 4. But we're going to go back to it again. So we're going to talk about graphing using x-intercepts. So we've already know how to graph when it's from factored form using our x-intercepts. But now we're going to work on getting it to factored form and then finding x-intercepts from there. So this is more like a review lesson than it is of new material. We can find a vertex by using our x-intercepts when we have an equation in factored form. So let's find the vertex of the following. So if I was looking at this and I wanted my vertex, I would start by finding my x-intercepts. So first step is x-intercepts. So remember that happens by setting y equal to 0. And then I'm going to take each set of brackets and set that equal to 0. And, whoops, so I'm just going to do that. Setting each bracket equal to 0 and solving for x. So let's add 2 to each side. I get x equals 2. Let's subtract 6 from each side. And I get x equals negative 6. Okay, once you have your x-intercepts, remember your x-coordinate of your vertex is the midpoint between your x-intercepts. So we're going to have to use our midpoint formula, which isn't hard. Remember, that's just average. So we're just going to take this 2 plus negative 6. We're going to add them together, divide by 2, which is going to give me negative 4 over 2, which is negative 2. So that is my x-coordinate of my vertex, is at negative 2. In order to figure out where your y-coordinate is of your vertex, you're going to have to take that value and sub it into your equation wherever there is an x. So y equals 3, bracket, negative 2, bracket, negative 2 plus 6, bracket. Okay. Negative 2 minus 2 is negative 4. Negative 2 plus 6 is a positive 4. 3 times negative 4 is negative 12. Negative 12 times 4 is negative 48. So my vertex then is at negative 2 comma negative 48. All right. So like I said, this is a little bit of a review. We've already seen this before, but we're going to start by finding our x-intercept. So that's 1. Then 2 is they're finding your midpoint between your two x-intercepts. And then the third step is to plug it back into the equation to get your y value. And then we can use these 3 points because now what we have are actually 3 points. We have 2 x-intercepts and we have a vertex, and we can go ahead and graph what the quadratic looks like. So find the vertex of the following, then graph the equation using the x-intercepts in the vertex. So they want us to actually use the x-intercepts in the vertex. So I'm going to start with my x-intercepts, and my x-intercepts are going to come from setting y equal to 0 and then factoring it. All right, so 2 numbers that multiply to 3 but add to 4 are going to be a positive 3 and a positive 1. And then I'm going to take each one of those brackets and set it equal to 0 and solve for x. So subtract 3, subtract 3. I get x equals negative 3. Subtract 1, and I get x equals negative 1. All right, so negative 3 is here, and negative 1 is there. Okay, so that's the first step. Second thing we're going to do is we are going to find our x-coordinate of our vertex by adding our 2 x-intercepts together and dividing by 2. And we get negative 2. So x equals negative 2. And then, of course, we're going to plug that back into our original equation. Whoops, plus 4 times negative 2 plus 3. So 4 minus 8 plus 3, which is going to be a negative 1. So we have, whoops, negative, that should be a negative 2. We have a vertex then at negative 2, comma, negative 1. Here's my vertex. Negative 2, negative 1, which is right here. All right, and then now that we have these 3 points, then we can draw our parabola to go through them. And there's our quadratic equation. Now, let's see what else we're asked to do. Let's graph another one. Okay, so this is a good chance for you to practice. So pause it here. In fact, I'll put both of them out right there. Pause this video and give it a try yourself, and then come back and see the solution. All right, so let's take a look. I'm actually going to go down here to do the work here on this one. So this is decomposition. 2 times negative 4 is negative 8. It has to add to negative 7, which is going to be a negative 8 and a positive 1. So 2x squared minus 8x plus 1x minus 4. And then I'm going to take out a 2x, so 2x minus 4. I'm going to put a marker of a plus 1 to give me x minus 4. X minus 4 is my common set of brackets, and 2x plus 1. And remember that equals to 0. So I have, whoops, x minus 4 equals 0, and 2x plus 1 equals 0. Add 4. Add 4. So x equals 4. And subtract 1, 2x minus 1. Nope, 2x equals minus 1. Sorry. Subtract 1. So 2x equals minus 1. Divide by 2, divide by 2. So x equals negative 1/2. All right. So 4 and negative 1/2. And then from there, I'm going to add those together and divide by 2. So 4 plus A negative 1/2 means 3.5. So 3.5 would be 7/2. Divide by 2, which is going to be 7/4. Okay, so I get that this may be difficult to graph, like 7/4 if you're trying to figure out where that is. So feel free to put this as a decimal. So that's 1.75. That's my x coordinate. So 4 minus 0.5 is 3.5. 3.5 divided by 2 is 1.75. So 1.75, that's what's going to go back into my original. So y equals 2 times 1.75 squared minus 7 times 1.75 minus 4. Y equals. All right, I'm going to get out my calculator for this one. So 1.75 squared, and then times that by 2 gives me 6.125, and then 7 times 1.75, so that's going to be minus 12.25, and then minus 4. Y equals, so 6.125 minus 12.25 minus 4 equals negative 10.125. All right, so 1.75 comma negative 10.125 is going to be where our vertex is at. We're going to have to just approximate it a little bit on our graph. It definitely will not be exact, but let's go up to our graph. So I'm going to start with my x-intercepts at 4 and negative 1/2. So 4 and negative 1/2. And then my vertex is at 1.75 comma negative 10. So it's like down here somewhere. And then our graph would look something like that. Okay, and the last one over here at C. So this is actually a really nice one to solve, x squared minus 4. This is a difference of squares. So remember, we take the square root of our first term, square root of our last term, and then put a plus and a minus in there. So when I set each of those equal to 0, like so, I end up with x equals negative 2 and x equals positive 2. And the really great thing is that when I add those together and divide by 2, what I get is 0/2, which is 0. So as I'm going to plug 0 back into my equation, I get y equals 0 squared minus 4, which just means y is going to equal negative 4. So 0 comma negative 4 is going to be my y-intercept. So if I look at this, I'm going to have y-intercepts. Let me go back up at positive 2 and negative 2. And then I have this positive 2, negative 2, and then negative 4, which is right there. And then my graph looks like that. Just it looks like a parabola that's been moved down 4, right? That's all that looks like. Okay. So definitely there's kind of a step process here. First is finding your x-intercepts. We do that through factoring. And then once we've found our x-intercepts, we add them together, divide by 2 to get our x-coordinate of our vertex. Once we have the x-coordinate of the vertex, we can sub it back into the original to get our y. And that gives us our graph. Okay. So let's look at finding some equations just as a reminder, depending on what you're given. So in this case, notice we're given our x-intercepts, which means we're going to find our equation in factored form. So x minus r, x minus s. So in order to do that, I'm going to need to take my x-intercepts and put them back into the brackets. Remember, when we put them back into the brackets, they change sign. So they go from, if they're positive, they go to negative. If they're negative, they go to positive. So let's start here. And I'm going to put my first x-intercept, which is at a negative 2, back into my brackets as a positive 2. And then I'm going to take my next x-intercept, which is at a positive 4, And when it goes back into the brackets, it goes as a -4. There we go. So we have half of it done just like that. The next thing is we're solving for this a. We need an a value. So thankfully, they gave us a point. And every point on a graph is an x and a y, which means wherever there is an x, I can replace it with a 2. And wherever there is a y, I can replace it with a 16. So that gives me 16 equals a, bracket, 2 plus 2, 2 minus 4. 16 is equal to a times 4 times -2. Well, 4 times -2 is -8. And then let's divide each side by -8. Excuse me. Which gives me -2. All right, so a equals -2, which means now we can write our equation. We have all our information. Y equals -2, x plus 2, x minus 4, just like that. And that's the equation that matches that graph. So if you're given x-intercepts, we definitely want to use factored form in order for us to find an equation. Okay, so how about something like this? So we have a parabolic arch bridge. A horizontal bridge is in the shape of a parabolic arch. Given the information shown in the figure, what is the height, h, of the arch 2 feet from the shore? Okay, so this is where, when you're given a picture of something, you want to create a grid on it, okay? So you want to draw it out with a grid. So if I was going to draw this out in a grid, I'd probably draw my grid like this, and then I would put the arch like that. Now, if you want to put your arch right in the middle, you can. It's all good, but I like to look at it like this. So this is at 0, and this is at 20 feet, and this tells me it's 10 feet high, and that would happen at 10. So this point right here is at 10. And then what they're looking for is what is the height when it's 2 meters from shore. So 2 meters from shore, that would be at the 18 mark. And they're actually looking for this height right here. Well, in order to do that, we need an equation first. You have to decide what type of equation that you want to use. You can either use vertex form or you can use factored form. Either one is fantastic. It does not matter which one. So I would say, let's go ahead. We've been doing so much with factored form. Let's keep with that. So let's do factored form. But if you want to put this in vertex form, you certainly could. And factored form, we know x minus r, x minus s looks like this. So my first x-intercept is here at 0. And I can put that back in as an x minus 0, or I could just leave it as an x. Either still works. And over here at 20, when it goes back in, it becomes a -20. So it looks like this. And then we have this other point. So my other point is actually my vertex, and it's an x and a y. So that means wherever there's a y, I'm going to put a 10. Wherever there is an x, I'm going to put a 10. Uh, 10 minus 20 is -10. 10 times -10 is -100. And 10 divided by -100, you can either write that as, well, there's a whole bunch of different ways that you can write that. You can leave it as -10 over 10 over -100. You could write that as -1/10. You could also write it as -0.1. It's all the same. But that gives us an equation, which is what we want. So I'm going to call this -0.1. X minus 0, so I'll just leave it as x, and then x minus 20. All right, so we want to know what the height is when it's 18 meters across. So I'm going to go in, and wherever there's an x, I'm going to substitute in that 18. 18 minus 20, which is -2. And now with my calculator, I'm going to go negative 0.1 times 18 times -2, and I get 3.6. So therefore, the height is 3.6 meters. Okay, notice we couldn't actually, or feet. I guess we're not talking about meters, we're talking about feet. So notice we could not answer this question until we had an equation, and we had the vertex and we had the x-intercepts. So it was up to us to decide, do we want to do factored form or do we want to do vertex form? You could do either or. I decided to do factored form, and then I put in my x-intercepts, and then I used my vertex for my x and my y to solve for a. And then once I had my a value, I was able to write my equation and then subbed in the 18, because it's 18 meters from the beginning over on our x-axis, into our equation to solve for y, and I got 3.6. Even if you had done this as a vertex form, you still should have gotten 3.6 feet as your height. Okay, great question. Great question. Okay, so just one more, and then we're done. So what's the maximum height of the parabolic arch? So we know from this, what do we know? We know that it has a span of 8 meters. So I'm going to draw this on a grid again. So this is at 0, and this is at 8. And then they actually give us a point. So they tell us from the midpoint, so my midpoint between 0 and 8 is at 4. So 2 spaces over from 4, which is at 6, if I go up here, it's 4.5 meters high. So that point right there is 6, 4.5. What they're looking for is what is the height. So again, we're going to need an equation. This time we're not given a vertex, so we're forced to use our factored form, which is fine by us. I'm going to begin by putting in my zeros, my x-intercepts. So there's one here, so x minus 0, so I'll just leave it as x. And there's one over here at x minus 8. So it's a positive 8, but when it goes back into our equation, it becomes a negative 8. And then we're going to use this point right here that they gave us. Wherever there's a y, I'll put in a 4.5. Wherever there is an x, I will put in a 6. And that gives me 6 times -2, which is a -12. Divide each side by -12, and a equals, so 4.5 divided by -12 equals -0.375. All right. Now we know the maximum occurs at 4, comma, whatever. So let's actually go ahead and plug in a 4 for x, because 4 is our halfway mark between 0 and 8. So we know our vertex is at 4, comma, something. All right, and again, I'm going to use my calculator here in order to figure this out. So -0.375 times 4 times -4, and I get 6. So what is the maximum height of the parabolic arch? The max height is 6 meters. Okay. So same thing, we still had to find our equation. Once we had an equation, then we could put in our information to solve for what we were looking for, which was the height of the arch. Okay, if you have any questions, make sure that you reach out.